In this next video, we're going to prove a trig identity that states that tan squared x over 1 plus tan squared x is equal to sine squared x. Well, we see here an opportunity to convert tan squared x into sine squared x over cos squared x. We're going to do that because that'll get hopefully all the trig functions in terms of sine and cos, and oftentimes that shakes free the correct answer. So splitting our page into left side and right side, we write down each expression, and then we're going to convert tan squared x to sine squared x over cos squared x as follows. So notice all we did is we rewrote the exact same thing. We said tan squared x over 1 plus tan squared x. But we converted, we converted each one of those tan squared x to sine squared x over cos squared x. Now, I see an opportunity in the denominator there to add 1 to a fraction, which means I'm going to get a lowest common denominator. So 1 over 1 and sine squared x over cos squared x, my lowest common denominator will be cos squared x. So I change 1 to cos squared x over cos squared x, and now this is what we've got. Now, I look in this denominator and I say to myself, hey, I can add those two fractions together because they have the same denominator. And I'm going to end up with cos squared x plus sine squared x over cos squared x. Okay, so this is the last expression we left off with. When we add them now, we get cos squared x plus sine squared x over cos squared x. Now, look at this expression right here in the numerator. Cos squared x plus sine squared x, we know what that equals. It equals 1. So in our next line, we can just say that highlighted part is equal to 1, like that. Okay, awesome. Now, if you look at what we have, it's just a fraction divided by a fraction. And when you have a fraction over a fraction like this, what you do is invert and multiply, invert the second one. So this is what we had at the bottom of the last slide. We invert and multiply. And we see when we do that, we can cross out those cos squared x's. And that means we're left on the left-hand side with sine squared x over 1. Now, we don't have to show the sine squared x over 1. We'll just call it sine squared x. And then we'll write quod erat demonstrandum because we've shown the thing that we were asked to show. And we'll go through the rest of these slides in future videos.